So guys, everyone joined, or we need to wait for anyone else?
Raghu, just give me a minute. I'll just check with the team. Is there
Yeah,
anyone?
yeah, sure, Mark. Thank you.
పేరు మార్చొచ్చు కదా. Chaitanya also joined. We are together, so we have joined together in one laptop.
Okay, then Raghu, then you can go ahead. You can start the session.
Okay. Thank you. Thank you, Mark. Thanks for the confirmation. Good morning, guys. Actually, sorry for the inconvenience. Our link today morning, it gets started by 5 to 7 minutes delay. So we'll try to be on time next time. I will discuss with our SSIT guys. Yeah. So let me share my screen. Are you guys able to see my screen?
Yes.
Okay. So
Yes.
today, okay, thank you. Thank you for the confirmation. So today we are discussing the below topics, and we are go a bit deep into it. And I just again just touches the virtualization and some basic stuff. And after that, we'll go for what is virtual machine and what is the virtual machines files we have and what is the purpose of each and every file. And after, if time permits, we'll go for what is cloning, what is snapshot and all. But basic, first we will start our basic stuff today. And according to you guys, any doubts for the previous small demo? You have any doubts or any queries before we start? Okay, then we'll go for the stuff. So, guys, I just discussed about what is virtualization, right? In simply manner, I just written it over there. What we discussed like demo virtualization, it's a technology that transforms hardware into software. So it is not particularly about the VMware. It's not particularly about the Citrix Zen server or Microsoft Hyper-V. Which technology which transforms or converts hardware into the software, that technology will call it as a virtualization. It will allows multiple operating systems. Means in the VMware, you can run any operating system like CentOS also you can run as a virtual machine with the same ESXi host, or Red Hat, or Ubuntu, or Windows operating server operating system, or Windows desktop operating system, or Windows core operating system. Any kind of any flavor operating system we can run as a one of the virtual machine on the single computer or physical server or ESXi host. That is the major thing in the virtualization. So all flavors it will support. Even Mac operating system also we can run it as a VMware virtual machine. So that too, all virtual machines we can manage from the single console also. That is the major advantage of the virtualization. The simple thing, virtualization means it will transform the technology from hardware into the software. At the same time, we can run multiple operating systems as a virtual machine on the single ESXi host. At the same time, each and every virtual machine, it work like a individual physical machine. That is the great thing in the VMware technology. That means if you're taking RDP or MSTSC of the one machine, you guys don't know whether it is physically running on the some physical CPU, memory and operating system, or it is running on an ESXi flavor with virtual machine. So the performance is almost equal to the physical machine, and we can work it as every virtual machine working like a individual physical machine. This is the basic virtualization things. How it look like means. And the same way, if you see here, this is the physical hardware what we have. Here VMware we are saying. What do you mean by VMware means? We have ESXi host. ESXi host, it's an ISO image, and in the directly physical bare metal, we will install that ISO image how we are installing some operating system kind. Means here the way of installation bit different. Like if you need to provide some root credentials like a username and password, and then you need to provide of course IP address like every operating system we require. And that ESXi host, we are able to launch from the web browser using what IP address we are assigning to the ESXi host. In coming classes, I will let you know guys how we are installing the ESXi host, how we are configuring the ESXi host. That information also I will provide. In that VMware layer ESXi host, will create new virtual machine. While creating what we require, hardware, RAM, we can take it from the physical server. That is, for example, 64 GB physical server RAM will be available. That means you can give some 4 GB, 8 GB as per your requirement for the virtual machine. Up to 80%, even though 85, 90% also people are using almost all the resources on the ESXi host physical layer, and will create as a individual virtual machines. Even for every virtual machine, we will assigning the some hardware, and top of that, again, we are installing the operating system. And top of that, what are the applications? Why we creating the virtual machine? The same applications also we are installing. That means one physical server, multiple virtual machines. That is the major advantage of the VMware or virtualization platform. We just want to a bit deep and small clarity about the things. So last class also we discussed about the hypervisor stuff. So hypervisor, it is nothing but irrespective of what virtualization technology and how you are installing using, we have VMware ESXi host also will call it as a hypervisor. Microsoft Hyper-V node also will call it as a hypervisor. Citrix Xen server also will call it as a hypervisor. But in hypervisor, we have two kinds of hypervisors are there. One is like bare metal hypervisor. Another thing we'll call it as a hosted hypervisor. What is the difference? Why we are bare metal and hosted? Very simple. If you have, for example, you have the physical server. In top of that, you install some Microsoft operating system. Okay, that is Microsoft server operating system, any 2016 or 12 or 2 or 2019 or 2022. So you all as like normally what we'll have physical hardware, top of operating system, then we are installing the applications. In the same way, physical hardware and top of that you have Windows operating system. In Windows, they have one feature that is called Hyper-V. If you go to the roles in feature, you can enable that one as a feature. That is not as like a complete physical hardware is running with the Hyper-V. That is called as a feature. If you enable that feature, those kind, and then still you can create virtual machines in the Microsoft Hyper-V node. So that is called as a hosted hypervisor. That means in our physical server, you install some operating system. In that operating system, we have some feature. That feature we are able to create the virtual machines. So those kind of hypervisors will call it as a hosted hypervisor. So that hypervisor hosted on some operating system. Bare metal hypervisor means like what we discussed about the ESXi host, means physical hardware directly we installed the ESXi host. ESXi host, a major thing what it will have, SDDC layer. What do you mean by SDDC layer? Means software defined data center layer. Simple. It will convert the physical hardware into the software, and we directly deploy into the physical hardware. Bare metal itself, we are directly deployed, and then we'll start creating the virtual machines. That hypervisor will call it as a bare metal hypervisor. So bare metal hypervisor, that means physical hardware, direct ESXi host, virtual machines. Hosted hypervisor means physical hardware, any of the operating system, whether Linux or Windows, and top of that, we are using those features to create the virtual machines. We'll call it as a hosted hypervisors. So this is the major difference between the bare metal hypervisor and the hosted hypervisor. If you see this diagram, we are able to understand here x86 architecture, it is nothing but the physical hardware. In that, You can create Windows or Linux operating system, and top of that, you don't have the VMware server layer. Directly application operating system means we'll call it as a hosted hypervisor. And we have the physical hardware x86 architecture. You have, and top of that, immediately you have the VMware server. We don't have the Windows Linux operating system. And top of that, if you create the operating system and application as a virtual machines, we'll call it as a bare metal hypervisor. So these are the basic things, virtualization and this one. And now we need to know more about it. For example, if any one of you guys go to the data center, and how the data center look like, we have racks. In that racks, we have physical servers. In that physical servers, all some cables are connected to the network switches, and some cables are connected to the storage controllers, and some cables are connected to the monitors. So they are occupying the more space in the data center, each and every physical server. At that too, it costs very high. It costs very high. Physical server depends upon the configuration. It costs very high. And then you need to maintain the data center with some 16 degrees or less than 16 degrees temperature, depends upon the how many servers you kept in the data center and how much heat is generating from the physical servers. And then every day one person need to go to the inside and check all the AC and powers, whether we have two power ports are enabled, all physical servers are working fine, any amber lights are there, or any physical hard disk failed, or any DIMM failed, or everything we have to be monitored. We require separate team to monitor the physical servers. So according to cost, see, whatever business you are doing, every business requires the infrastructure, correct? In infrastructure, always cost is the primary for the business. So if you want to create some servers and then you require some physical servers and data center maintenance and the team maintenance and the alerts and the configuration and the AC maintenance and rack units consuming space and the storage cables and network cables, all these things cost like anything. So VMware is the greatest solution. What it will use, even though it is Azure VMware or Citrix server, the major virtualization, what it will use, it is very less cost effective comparatively physical servers. Why? Because instead of 10 physical servers, we are creating one physical server with 10 virtual machines. One thing. And another thing, you have one project. Okay. In that project, you got, so for example, 100 machines you require to finish that project. And ongoing project and client requirement got changed. Immediately, you require some 150 machines. So normally offices, how it will be, you have one physical CPU, you have one monitor, one keyboard, one mouse, and then you required multiple, suddenly 50 machines got 50 users requirement is increased, means again you need to purchase for the 50 machines, and then all these 50 machines you have to configure, and every user is required, and that after 2 years that project gone, and the next project you required only 25 users, and remaining 125 physical machines are getting impacted. So one way, from the data center high level, it is too much cost effective. Another level is the user level to support the client. So if you have the physical server and you can create the some 50 machines or 100 machines, because you will get as per your requirement, one physical server, you will increase the resources. Instead of 128 GB of RAM, you will take 512 GB of RAM physical servers. And then we have thin client and zero client. That means that is not cost like a physical desktop. Means that CPU cost and everything will get reduced, because it will come like a compact small box kind of stuff. Thin client and zero client. After this class, you can search in the Google to understand like small things, and it will, what is the hardware is required to connect to your virtual machine, that much only there in that, and it is the cost effective. For example, if you go for the physical desktop, it is cost around some 18,000 to 22,000 as per your requirement, and these things are some 8,000 or 9,000 only, thin clients and zero clients. And using that clients, you have multiple virtual machines, and whenever project got increased, you will create more virtual machines from the single console. Whenever project got completed, you just remove them from the inventory or delete from the disk physical virtual machines. Then comparatively user point of view also, virtualization is the very effective, cost effective. At the same time, we are elasticity. That means you can increase the count or you can decrease the count. In the same way, if you come to the Azure platform or AWS platform, what we will do? You are also no need to maintain entire physical stuff. You have the thin clients and your virtual machines also running on the VMware ESXi host only, but not on premises. That Azure people, they are creating your virtual machines on their own data center, and using the Azure platform, they are providing the connectivity to the user. So suddenly your project team need to increase, and then whatever the request you are asking, like Azure, oh now 50 machines are there, so I require 50 more machines, and then 100 machines you will get from the Azure. Your project got completed, then you just reduces from the 100 machine to 50 machine. That means it's completely cost effective and electricity. Elastic means you can, if you want you can increase, if you don't want you can decrease the count, and depends upon how many machines are using, only the rents we need to pay to the Azure platform. Even in the on-premises point of view or Azure point of view, all VMs are running on the VMware platform. In on-premises means internal network user will get the VM virtual machine, assigned virtual machine. In Azure platform means user will get the virtual machine from the internet. So this is the major advantages: cost effective, and data center maintenance cost effective, and user maintenance cost effective, and easily increase the virtual machines and easily decrease the virtual machines. And fifth point is something like security point of view. So instead of you are using some physical server and some operating system, you will get Microsoft security patches to secure your operating system. But we have some 2 layers and 3 layers security point coming to the VMware. What is the mean by security point? Means in VMware ESXi host also we have the security patches. Means we nobody unable to hack the VMware ESXi host if we are doing cumulative updates and security updates in the timely manner. That is one layer of security. And what operating system you are using, in that operating system also you will install the patches, right? That is another layer of security. And this is the security point of view. It is very stable. At the same time, cost point of view, elastic point of view, data center maintenance point of view, user point of view, budget point of view, virtualization is the best solution. And these are the major advantages of the virtual machine. So now we are talking virtual machine, virtual machine, virtual machine, virtual machine. I just want to know very clearly exactly what is virtual machine. We are talking about virtual machine, virtual machine. So I just want to know what, I just want let you guys know what is the virtual machine. So leave about, as of now, what are the things in your mind about virtual machine as per your previous step. I will tell very easy and very clear understanding about the virtual machine. Simple thing. Virtual machine is nothing but the group of files. Huh? Is it Raghu? Raghu, is it correct? You are saying this many things about the virtual machine. Simply you are saying like virtual machine is just files. Yes, it's true. Virtual machine, it is nothing but a group of files. So what is those files and what is the use of those files? I will explain you guys. For example, if you go to the VMware virtual machine, and while you creating the virtual machine, what you guys needs to do? Simple. We need to give some hard disk, and we need to give some RAM, and we need to give some CPU, and we need to assign some network. That means every operating system, what it is required? Hardware. Hardware, it is nothing but network, storage, and then computing resources, CPU, RAM, right? So after you are creating, after you are creating the virtual machine, whatever the storage you are giving, right? You have multiple data stores. For example, you have dev data store, you have QA data store, you have production data store. You got request from the dev virtual machine need to be created, and then you will select the dev data store, and then the VM will be created on the dev data store. And if you go to the data store, you are able to see the virtual machine folder, because most of you guys are already working on the VMware. Hope you guys saw some folders in the data store with the virtual machine names folder, and that folder consists of what is the, you are able to see my screen, right? So these are the files that folder consisting inside. That means virtual machine is like a folder, and that folder consisting of these files. This is what virtual machine files, and those virtual machine files, what is the use of these files? We have VMX file, VSWP file, VMSS file, NVRAM BIOS file, VMDK file, VMDK data, and VMD and delta.vmdk file, that is called snapshot VMDK. So what all these things? This is the virtual machine, and it's consisting of all these files. How one hardware is working like a software, converting the software, and that software is as like a physical machine it is working. What is the magic happened behind that? And as a technical guys, you guys need to understand, because why I am taking all these small things also into deep, because you guys require the real-time environment experience, and whenever you guys triggered some issue, and if you know the complete base should be strong, and the way of troubleshoot, the thoughts will be generated on your mind. That's why the basement is the very important. So that's why I'm insisting each and everything on this manner. So if you go to the virtual machine files one by one, so at the same time, we will compare with the physical machine to get more understanding. Okay. If you go to the virtual machine files, the first thing is .nvram. .nvram contains the BIOS. BIOS means everybody knows. Even if you restart your laptop, and as per your vendor like Lenovo, Dell, everybody have one small, you need to click F2 to go to the BIOS, you need to click F6, F8, F10, you will go to the BIOS. What BIOS will be do? That means if you have the physical machine and you have some problem with the physical machines, or you want to use some special features on the physical machine, and your machine needs to be boot from the different ISO image, because you want to upgrade from one OS version to another OS version, and another OS you are inserted as a disk in the DVD drive normally in the physical. Otherwise, you can convert your USB into the portable ISO, and then you connect your USB to the physical server, and you need to boot from your operating system from the bootable device, which is your priority, DVD drive or USB. In the same way, virtual machine also have the BIOS, and whatever the physical machine BIOS operations you are performing, all BIOS operations we can perform from to the virtual machine also. That can be taken care by the .nvram file. So .nvram file is used to perform the BIOS related operations from the virtual machine. So in physical machine, what are the things we are able to perform? Virtual machine also we are able to perform. But here the thing is, in the virtual machine, we have the files, and that files will perform that respective task. So that is called .nvram. .nvram, it contains the BIOS that used to part of the reboot process. And if you want to upgrade your virtual machine, and you want to connect some ISO image, and you want to boot your virtual machine from the boot menu or BIOS menu, or boot from the ISO, and all these options we are able to do for the BIOS level like a physical machine using .nvram file. So if your .nvram file got corrupted, your machine unable to boot from the ISO, unable to boot from the ISO, correct, and unable to process from the BIOS. So in that point, .nvram will be important. And in future, I will let you know in the troubleshoot point of view, because phase 3 is the most interesting thing. Means we can understand so many issues are coming, how we will troubleshoot, how we need to think, and one issue, how many ways of troubleshoot we can perform. We will discuss all these things on the phase 3. And second file is .vmx file. So .vmx file contains the configuration information and hardware setting. That means you are assigning some RAM, and you are assigning some CPU, you are assigning some hard disk. All this configuration information will be available on the .vmx file. All configuration information of how many NICs you are assigned, and what is your NIC MAC addresses. And in NIC, we have VMXNet 3 or E1000 or E1000E. Some kind of versions are there, depends upon the operating system. You can select those versions. All the configuration information available on the VMX file. If you increase, initially you created VM with 4 GB RAM, and then you are increased it to 8 GB. And that information also, updated information also will be saved on the .vmx file. All configuration information will be saved. And .vmdk. This is very important and very nice .vmdk and delta.vmdk topics. Why? Because you guys will get more questions from this one only. What is the difference between .vmdk and delta.vmdk? I will let you know. See, in the physical machine, also we have the physical hard disk. In that physical hard disk only our operating system will sit, and then you are creating the drivers after operating system installed with the available physical storage, physical hard disk, C drive, D drive, E drive, and you are using those drives to keep your data or for any application purpose. In the same way, virtual machine also have the hard disk. So all this hard disk and hard disk data and all these folders and files from the OS level, and all this will be saved on the .vmdk file. So if you see that .vmdk file is exactly equal to your virtual machine while you creating how much GB you are assigning, in the same way that much of .vmdk file size will be. That means this is your data file. This is your data file. We'll call it as a virtual disk. That means everything is virtual. We are not able to see like a physical hard disk, right? We are able to see like a virtual disk from the ESXi console or vCenter consoles. And that virtual disk, we'll call it as a .vmdk file. And that .vmdk file consisting of whatever physical disk consisting of folders and data and everything, in the same way .vmdk file consisting of all these data, folders, everything in the virtual machine layer. So now virtual machines, we have one greatest advantage. If I tell that greatest advantage, then you can understand delta.vmdk file very easily. What is that greatest advantage? That is VM snapshot. Why that will be the greatest advantage? Because every machine we can't run with the same versions, or we will get more updates for the application layer point of view, or we'll get more updates from the OS security patches or cumulative patches. So that means you need to do some modification your operating system after some time. But here the problem is you don't know what will be the impact. So you upgraded one application, and after that your SQL DB is not communicating. And that is your production infra, and that is the very business critical application for you. Even if it is down for the 1 minute or 10 minutes also, you will get impact. Your business will get impact. So for that kind of critical missions or whatever changes you are performing from the OS level, and if something is not working as we expected after the changes done from our side, and then the snapshot, that means you just go virtual machine, right click, take snapshot, and once snapshot completed, you can log into the machine, you do whatever changes you want. You just mix it, update it, whatever the things you want, you just perform it. And the output is not expecting how you are expecting. It's not like that output. And then it is the business critical application, and whatever the downtime you took to perform this activity, that's already going to end, but you are unable to fix the issue. In that situations, snapshot, what it will do means just same VM, right click, instead of take snapshot, reverse snapshot, you just click it, and then before application upgrade, whatever the state will be there, that state it will be converted. That means before installation, what is the VM state, it will be reverted to that state. That is the greatest advantage. That means whenever you are taking the snapshot, it will capture the exacting state, exact accurate state of the virtual machine, and then you do all the performances, and after that you revert back, it will be go to the next means before reverse snapshot. If everything is working fine, and then you can just delete the snapshot, then automatically whatever the modifications happen, it will be merged. So Raghu, you said it is very seriously, it is a very good feature in the VMware snapshot. So as a technical guys, I want to know what is happened in the background, how it is possible. You are doing all the modifications, and then suddenly, like a time travel, you are simply going back to the previous state. Yes, that is what VMware succeeded now, because whenever you are taking the snapshot, two files will be created, because virtual machine is nothing but the group of files only. So before snapshot, those files are not there, if you see, and after snapshot, you are able to see some two new files will be created for one physical disk attached machine. Physical disk nahi, virtual disk. So what is those files? The first one is .vmsn. .vmsn, it is nothing but the snapshot file. That's it. And another file will be delta.vmdk file. Delta.vmdk file. So what will happen means whenever you are creating the virtual disk data files are only used when snapshots are created. Delta.vmdk. When a snapshot is created, all writes to the original .vmdk are halted and it becomes read-only. And change to the virtual disk are then written to these delta files is instead. That means once you take the snapshot, one delta.vmdk file will be created. So why you are taking the snapshot, you want to do some upgrade. Upgrade is nothing but what? Some modifications. Modifications is what will happen, that a new upgrade file, you keep it on your machine and it will consume some data. And while you are upgrading, what will happen? It consumes some more data. And all write operations, if you are writing something on the registry, something on the DB, something on the application, everything is write operations only. So all write operations fall under the delta.vmdk file. All read operations, all the .vmdk file. Another way we call it as a parent disk. And delta.vmdk file will call it as a child disk. Once you take the snapshot, all write operations fall under the delta.vmdk and all read operations only stick on the .vmdk. So now what is happened? What modifications happened? We completely separated. What modifications happened after snapshot? We completely separated. So if the data after modifications or after upgradation, your virtual machine is not working as we expected. So what we will do, revert back the snapshot. That means your .vmsn file will be mounted to the .vmdk physical disk. That, and whatever the write operations happen, it is all are kept in the delta.vmdk. So there is no modifications in the .vmdk. That means before snapshot, what will be the state? The same state VM will be go. If everything is working fine, all looks good, so now no need to revert back. At that time, what will happen? You just delete the .vmdk file, and then whatever the data will be there in the .vmdk file, it's automatically merged to the delta.vmdk file to .vmdk file. That means whatever modifications is there, now it becomes to the .vmdk. Once a snapshot got deleted, after deletion, your .vmdk will be the only disk and it have the modifications. So this is the background thing happened. Read and write operations will be differentiated. Or after snapshot, write operations fall under the delta.vmdk file. And whenever you want to revert back, you need to just go to the .vmdk file. And if you want to, no need to revert back, you just delete delete delta.vmdk. That means you just delete the snapshot. Then automatically, whatever the modifications are there, all will be merged to the .vmdk file. But we have one small clause here. That means you can't keep the snapshot for the long time. Why? Because if you keep the snapshot long time, all write operations fall under delta.delta.delta.delta.delta.delta. Then the delta.vmdk file size will be increasing like anything. At that time, if you want to merge it, it is pretty difficult for the .vmdk file to merge to the delta.vmdk file. That's why VMware always suggested just keep your snapshot 72 hours only, then not more than that. Just do your activity, whatever you want to do, and then you can create it, and then you can get back to the original state and then remove your snapshot. So why we no need to why we don't want to keep the snapshot for the long time, I will tell in the different way also. For example, your .vmdk file is 100 GB. Okay. And while OS creation, while you creating the VM, you create the same .vmdk file, right? So it will consume around 30 to 40 GB. So now you have 60 GB only free space on your .vmdk file. And then you want to do, after some days, you want to do some modification, and then you take some snapshot. And after you are taking the snapshot, what will happen? Delta.vmdk file will be created, but delta.vmdk can be increased up to 100 GB from 0 GB. That means because the parent disk is the 100 GB. So delta.vmdk file also be the 100 GB, but parent disk already consumed 40 GB, but a delta disk, it's have up to 100 GB, and you are not deleting the snapshot, continuously perform write operations on the delta.vmdk, and if it will be grow up to 100 GB, but if you want to merge it, .vmdk file will be only 100 GB. In that 40 GB already completed, that means 60 GB only available. But the delta.vmdk file is 100 GB. How you will accommodate 100 GB of delta.vmdk files to the, how you will accommodate 100 GB of delta.vmdk files to the 60 GB of available space in the .vmdk file? At that time, VM will be corrupted. So at that time, VM will be corrupted in the sense, so delta.vmdk file should not be increased up to the .vmdk file. That's why VMware is suggested to perform the snapshot deletion within 72 hours. Hope you guys are very clear about this topic, right?
Got it, but I do have a simple doubt here. Suppose if we create one more snapshot on one snapshot, I'm trying to create another snapshot. So we are going to create another delta.vmdk file.
Correct.
Making it as
Another delta.vmdk file will be created. So after the snapshot, whatever the write operations performing, it will be saved on the second delta.vmdk file. So now you have two checkpoints. So before snapshot and after snapshot, you created one more snapshot, right? So up to two checkpoints, you can revert back your VM.
Okay, so you can revert back. So if I want to merge the VMDK and delta 2.vmdk, that's not possible, right? Is that possible?
Yes, it's possible, because
Okay.
everything is isolated. One .vmdk, one delta.vmdk1 and delta.vmdk2. And if you want to keep snapshot 1, that is okay. If you don't want snapshot 1, means snapshot 2, because snapshot 2 already have the .vmdk and snapshot 1 files, because after snapshot 1 only we are taking snapshot 2, right? You got it?
Yeah, got it.
So
Yeah.
obviously we are able to merge it.
Yep, fine. And so the VMSN file is going to maintain like how many snapshots you are taking and the relation of it, or
That
what
means,
what will be the content in VMSN file?
VMSN, it is simply like you want to be either merge or you need to be delete. So that point, the VMSN file simply just mapping the checkpoint of the virtual machine, whether it should be .vmdk or it should be delta.vmdk1 or it should be delta.vmdk2. That's
Let me think.
information. Yeah, that
Okay.
information only it will take care. And entire data will be fall under .vmdk, delta.vmdk1, delta.vmdk2. The .vmsn file size also, it is very less. It is not even comparatively to the actual .vmdk file size.
Okay. And when I'm creating a snapshot, you said that delta.vmdk file will be created with 100 GB of space. So while creating a VM, if I give a storage space as 100 GB, so that VMDK file will be of 100 GB. If I create one more delta.vmdk, how is it going to get one more 100 GB when at the time when I'm creating a VM, I gave only 100 GB, right? So
Correct.
now it becomes 200 GB.
That's why it is in their point of view, how much virtual disk size we are giving, the same size delta.vmdk file will be created, but you are unable to use the complete size, because as per the availability, it is all just manipulating their .vmdk file from the VMware layer. But reality is already 40 GB consumed for the OS, only 60 GB available. That's why VMware strongly recommended don't keep your snapshot for the long time and don't perform more read and write operations on that. Just do your activity and then revert back.
Okay, so there will not be any duplicate copy with the .vmdk and delta.vmdk, right?
No duplicate,
Will not
because
be.
read
Okay.
operations fall under .vmdk, write operations fall under the delta.vmdk.
Sure.
So accordingly only we can perform.
Thank you, Raghu.
Yeah, no problem. So any other questions, guys?
Yeah, I do have. As Priya asked just now, so whenever we are creating the snapshots, this delta.vmdk is completely using the leftover ways which we didn't assign for the virtual machine, right?
Okay.
This might affect with the other virtual machines which are running, right? will that or it will not?
Sorry, I didn't get you. So you are saying like one virtual, your voice is also breaking. Hello?
Hello,
Yeah,
are
yeah.
you able to?
Still some noise. Are you guys also getting same kind of noise, or I'm only getting?
So did you got my question or do I need to ask again?
Yeah, yeah, please come again.
Okay, so as Priya asked just now, like VMDK file .vmdk file is nothing but the how much the hard disk space that we assign to the virtual machine. So
Okay,
whenever we are creating a snapshot, the delta.vmdk file will be created.
correct.
You mentioned that this will not use the space which we assign to the virtual machine. Like it will uses the completely other space. Like
No, no, no,
so,
no. It will get from the virtual machine only. Why? How it will get other space? That's why it will be showing virtually 100 GB, but it can be used. What is the space left from the .vmdk only? Because this is the child disk from the parent disk. Got it?
okay. So even though it's showing like for some like if we have only 60 GB left over, but still the delta.vmdk will show this 100 GB.
See, here it will not show like if you click delta.vmdk, right click properties, you can't see the 100 GB. It will be like how much space you are using, that much space it will show. For example, today you copied 1 GB, it will show 1 GB. Again, tomorrow you dump 1.5 GB, again it will show 2.5 GB. Like that. But that delta.vmdk file completely increase up to the .vmdk file size, but that is not recommended because .vmdk file already used some space for the OS, and you can't maintain up to that point that VM will be crashed. That means we can't adjust 100 GB on the leftover space. That's why
So
VMware recommended.
doesn't it throw any error? Like if we use more space, like the space has been utilized more than
Yeah, obviously, if you
it
keep
throws,
your
right? If
snapshot,
we
if
use
you if
61.
if you keep your snapshot for the long time, your VM's performance is getting degraded a lot. You can't
Okay.
it will give some sense, and it will went for the hung state, and you can able to see it. And
Yeah, yeah.
then we have some tools to run to get it, and then you are able to see from the RV tools report also how much snapshot file size, and then you can directly see from the data store also how much file size got increased. And if you created some alarms and alerts, it should not be exceed this much, and
Okay.
that will be throw also.
Okay, fine. It
Yeah,
makes sense. And so we can see the size of the VMD, how much space we do have in VMDK, how much space it is
correct,
utilizing in
correct,
delta.vmdk.
correct. We
Okay,
are
then
able
it
to.
makes sense. Yep.
Yeah. Any other questions, guys?
We are good, Raghu. I
Good,
am
good.
good.
Yeah, great. So normally all these things you just whenever you are thinking about one technology, so you just technology, even I felt personally like technology, you can treat it as a one character. So they have some characteristics, they have some plus, and we know how to handle that character. You need to understand in that way. In personally, my opinion, like VMware is like some human being, and they have some their own characteristics, and they have their own some the way of handling the things. So in the same way, you should understand from the how can I say, the spirit of the subject. Then you guys can troubleshoot easily whenever issue came, because every issue is an identical. You can't say every time we'll get same issue, but maybe the solution will be the same, because you can understand, then only you are able to see it. Okay. And now in the if you want to take the snapshot, there is some pre-checks needs to do. Pre-checks means whatever is the VM running on data store, right? The data store should have the minimum buffer space. That data store is required some buffer space to perform the snapshot operation. Why? Because if data store we have 95% got consumed, only 5% is left, then obviously whatever the VMs running on that data store, it will get impacted. Because if you see your mobile and it is 4 GB or 6 GB RAM, if you consuming almost 5 GB 6 GB of RAM, the performance will degrade. And your mobile have some 32 GB of free space, and it is almost reaching 85%, 90% is prompting clear some space, internal storage getting full, clear some space, some pop-ups we are getting. But that means whenever you are performing some operation on the data store, it is completely occupied, and most of the critical up to critical level it get occupied, it will get impacted. So we need to understand at least how much VM size is there, that much VM size buffer space should be available. Otherwise, in complete data store, at least 15% free space should be available to take the snapshot. And one more thing, the snapshot, it's not that much recommended if your VM size is 1 TB, because 1 TB VM size, if you want to take create delta.vmdig and you dump more data, it is still you can able to take the snapshot and still you can do, but it will be like some kind of taking pressure on the VMware ESXi layer. So you have to think, if you have 1 TB and you have to be that much free space available on the VM assigned data store, and still you have to closely monitor and delete the snapshot as early as possible. And third thing is, snapshot is that much not recommended which virtual machines have more write operations. How can we say more write operations means? If your virtual machine running with SQL DB means more and in and out operations will be there. So more out operations and more data is dumping and more write operations means obviously it will impacting. Correct, because that delta.vmdk file will be getting increased. So obviously it is getting impacted to the .vmdk file while it is merging or something. So if you're doing more and read write operations, but still it will not deny your request, VMware, and it is not throwing any error, but it will take some time. For example, it is more critical VM and snapshot is only the way to come out from this. In that kind of scenarios, you can do one thing. You can shut down the VM and try to take the snapshot, because if you power off, there is no write operations. Correct. So at least your VM will be some stable snapshot you will be available. So that is one way of taking the snapshot for the more IO operation performed VMs, but still you can take the snapshot, but better or recommended thing in that way. These are about snapshot and files, and some more files in the virtual machine files, and all these files we'll discuss on tomorrow's class, like RDM, vSwap, VMSN, like that. And any queries you guys have?
No, Raghu, we'll let you know if anything we have by recording tomorrow.
Yeah, super guys. Anything there, just let me know.
Yeah, sure.
So do we have the class tomorrow on the Saturday or else on the Monday?
Maybe Monday is fine. But tomorrow, if you guys are okay, I'm okay. I don't have any issue. Because I need to adjust something with my manager also. If we are for the Indian time, we have to be 7 means in Singapore, it will be 9:30 a.m. That's actually exact my office time. So for class and all, I want to get some information or some approval to every day come to late, because it is not one time task. So is it a 7 o'clock morning? Is it okay for you guys? Or you guys want to be evening classes also? I can do. It's up to you guys how the availability.
We'll let you know.
Yeah, sure, Mark.
We will discuss it.
Yeah, please. You just discuss with your team if you guys are okay with evening classes, and that will be great, and we can extend ourselves also, because morning means we are hurry. But if you are okay, but morning only available for us, we don't have any other alternative means, that is also fine. And if you guys want more concentrated on the weekend, we can extend ourselves, because weekend means Saturday or Sunday, 2 hours, 2.5 hours, or any queries or there, and that will be good. And I want to tell one more thing, like theory, always theory, and whatever I'm explaining, when you are listening, you are feeling like everything is understanding, but just try to do your own browsing and try to get more information on your own. And then if we discuss every day, first 10 minutes about the previous topics and doubts and all, 10 to 15 minutes, and then we'll go for the actual subject. Every day we have remember means it will be better registered on your our minds. So just do your background stuff and let me know any queries are there. If I know, I will tell you. If I don't know, I will search and I will get and I will let you know next day. Okay, na guys?
Yes.
Yeah, great. So is there? Just let me know. Tomorrow we will connect again. Have a great weekend, guys. Okay. And if you don't want tomorrow, Monday we need to connect. Just inform the SSIT accordingly. I will plan my day. Okay. Hello.
Sure.
Okay. Great, guys. Have a great day, guys. Bye bye. Any queries, or shall we wind up the call?
We can wind up the call.
Okay, guys. Bye bye.
Bye-bye. Are you playing right now?
They just don't have one.